Hello and welcome back to another episode of InstaBlinks. Today I am here with Hichem Kenniche to talk about Apache Spark 4.0 and what to expect. So Hichem, tell us a little bit about yourself really quick before we jump into the topic today.
Hey, Brian. Hey, everyone. Thanks for having me. So I'm Hichem Kenniche. I'm a product architect for Ocean for Apache Spark, which is a managed service offered by Instaclustr by NetApp that optimize the deployment and the operation for all the Apache Spark workload on Kubernetes. What matters here in this discussion is we will talk about Spark when it's running on Kubernetes. And under the hood, what we do is we use a lot of kind of cloud infrastructure optimization technologies to automatically manage and scale Spark clusters to ensure cost efficiency and high availability. I mean, from user perspective, I would say using our tool gives a lot of enhanced metrics, which is really important when debugging Spark, and also enable to better understand different bits and mechanisms that are happening under the hood. Spark when Spark running in Kubernetes. From prior joining Instaclustr, I have been holding different data roles in data world space, data engineer, data scientist, machine learning engineer, solution architect. So coming from like a user background, I would say I know a bit about data engineering and machine learning and the end user with a deep understanding of Apache Spark.
Awesome. Thanks. So I guess before we get into Apache Spark 4.0, maybe for those people that don't know what Apache Spark is, maybe you can give us a little bit of a background on what is Apache Spark and why it's so popular.
Yeah, sure. So Apache Spark is an open source. By the way, it's a major project within the Apache Software Foundation. It was born in the era of the Hadoop, which was, decades ago, and it's still around with all this rich ecosystem from Hadoop, who had this amazing, tech stack and data stack that still we're having today. So it's a distributed computing system designed mainly for big data processing and analytics. Everything pretty much runs in memory. That's why it's fast comparing to other frameworks and other approaches. It became really popular among data practitioner, more generic word, say, because funny thing is like Spark is like a really Swiss knife for data, big data specifically processing. It offers high performance and ease of use. I mean, you can run Python, Java, Scala, SQL. You can connect it with different data sources and data sinks. And yeah, it's versatile because it handles a large scope of use cases. You can do machine learning, you can do data engineering, BI, name it. So it's really kind of popular, and it becomes like a de facto in different, say, fields and industries, because it brings all these aspects to the data engineering and machine learning stack.
So maybe if we break it down just a little simpler as well, when you're dealing with, for example, big data, instead of going through everything, in a single process, Spark's actually taking that and breaking it down into a lot of different processes and working on it at the same time across multiple nodes. Is that a fair way of putting the how Spark works?
Yeah, exactly, absolutely. This is how it works, and by the way, like it sounds complex and sophisticated, but this is all taken away from the end user. I would say you don't have to understand how how this works under the hood, or how Spark managed to distribute workers on different tasks and jobs, and don't want to use all the jargon of Spark. But yeah, this is look at it like, if you have your CSV, you have your table or data, and it can run and fit on your laptop, that's great. But in more advanced word, we have big databases and data lakes and lake house, name them. and this cannot fit in one machine. And this is where you need clusters or like multiple machines, and Spark manages all this transformation and data crunching and model training and all this stuff, and can distribute and parallelize the work among clusters.
Oh, that's awesome. So that's a great kind of introduction into Spark itself. And you mentioned a lot of different use cases, but can you maybe uh, more specifically talk about two or three different use cases that we see a lot of customers using Apache Spark for?
Yeah, sure. So in within our customers at Instaclustr by NetApp, we have, I mean, I would say like, a lot of diversity in the usage of Apache Spark on Kubernetes. The major one, and somehow it was built for this, like, ETL and ELT transformation. Think about it, you have your data sitting or living or generated, in some data sources. You take this data, ingest the data, you transform it, and then you load it, or you load it and then transform it, depend on the approach you adopt, and you store it in a data lake or a lake house, or even in a database, or move it to some things like Kafka or other ingestion or transformation software stack. So ETL and ELT is the main usage, and we see a lot of personas allowed around data engineering. These are like the main users, I would say, so far. To think about it like in simple way, you just need to crunch and ingest a lot of data, do some summarization, cleaning your data, aggregate it, and put it in different layers, and then from there you can enrich it. Other business units or other data team will take it from there to enrich it, to expose it to a BI tool, or to create a machine learning model, let's say. This is one aspect, I would say, and the majority of the use cases we see in the industry and in the market of Spark usage. Other things, and this is getting more and more kind of adopted, is the machine learning aspect. Again, because data is huge, we're talking about big data. We need also to train models. We need to prepare data to train models and build models, so we can use, and Spark is mainly used to do all this transformation to train machine learning model, and you can train them in a distributed, in a parallel fashion, which makes a lot of sense when you have a lot of data. Things like Spark MLlibs and other libraries and other framework and approaches can be used with Spark to distribute and train machine learning model. And from another kind of usage, which is a mix between data engineering and machine learning, this is somehow what I tend to do on a daily basis, is like more from the ad hoc or the kind of exploratory, sorry, data analysis. You can just use any Jupyter or Jupyter-like notebook or VS Code server or your VS Code. You connect it to your Spark, and you just run like queries, interactive queries, to explore your data, to have an idea about your data before you move to QA or production. This is something also mainly used because, again, as an end user, as a data scientist, I don't need to understand. I mean, it's always good to understand, obviously, but I mean, all this technical aspects is managed ways, abstracted away from me. And then through my notebook, I can run PySpark queries, SQL queries, and I can run interactive kind of mode and interactive exploration through above of my data. And from, I'd say, just a few things here. If we think about verticals, like, we see a lot of financial services using Spark again, in ETL, ELT, or for machine learning, for ad hoc analysis. Think about it like, in this field, there are a lot of transaction going on. So you need like a high efficiency tool like Spark to analyze transaction in real time. This is another kind of cool feature about Spark. You can analyze and your data in real time, do examples like detecting fraudulent activities, fraud analysis, and stuff like this. We can see it a lot in other customers in retail and e-commerce. They use a lot of, again, like, Spark to do ETL, ELT, prepare data, and they'll build models, machine learning models, or even like, rule-based model to do a lot of segmentation and churn analysis. Yeah. So that's like, I took some time to explore different use cases of Spark in the real world scenarios.
Awesome. Yeah, thanks. So let's jump past the use cases now. And kind of the whole point of this InstaBlinks was to talk about what to expect with Apache Spark 4.0. So that's coming around the corner, right? Give us a little bit of an idea of what you think is coming or what we should be expecting to see from 4.0.
Yes, sure. So just a quick thing, like, as I said, like Spark was born in that era of Hadoop, and we had like different releases, Spark 1, Spark 2. And personally, by the way, I started really looking and taking Spark not seriously, I say this in a humble way, but like, really adopted in my previous experiences, started from 2016 with Spark 2.0, which brings a lot of cool and amazing features. One of them was the introduction of unified data frame and dataset API, the structure streaming API, and other things. And then we had major releases, Spark 3. One of them around 2020 was the support for Kubernetes. By the way, I mentioned that we focus on running Spark on Kubernetes at Instaclustr. So yeah, Spark support, for Kubernetes was GA starting from 3.1, and then for how we have different version and different kind of improvement to Spark through the major version 3. And Spark 4 is hopefully coming soon. We're really excited about this. And as I mentioned, every release of Spark, like any major software, open source software, comes with a lot of improvement and also bug fixing. It's just like normal. There was a lot of things that have been around to be fixed. And Spark 4, besides, bring a lot of cool new features. Some of them I can, kind of elaborate a bit. One of the key things is a bit struggling with the error analysis, the stack trace and other stuff. So we have an improved error analysis with structure logging that gives the developer a better tool to analyze errors and make debugging easier. And by the way, this is something we have been doing at Ocean for Apache Spark, our managed service offering, for a long time by bringing a lot of metrics and UI to our end users. A lot of improvement, real-time data processing, which is really amazing. Spark is really getting at a level we're expecting near real-time or real-time data processing, combining it with other major framework like again Kafka. It's two softwares and framework works really good together. We have a significant update around the API, which the Python API for Spark, which is called PySpark. We make it really easier to handle a lot of complex data workflows. We have a new Python data sources API, arrow optimize, user-defined functions, and other advanced things like polymorphic Python, UDF, UDTF. The major, I would say, I'm really excited about this feature that Spark Connect is GA. Spark Connect is a way to kind of decouple in a client server mode where you don't have all the dependencies in your client and you can run your code in Python, in Golang, in any language of your choice, and move all these queries to your Spark remote server running. And this is a pretty kind of nice way to make Spark more adopted by a large community of users. So yeah, Spark Connect is is really exciting feature that is coming with. It's going to be GA with Spark 4.
That's really cool because I think traditionally speaking, a lot of these individuals have been using Python, but there's, like you said, there's all these other languages that people are using, for working with data science, whatever use cases. And so this Spark Connect, I think, will really bring up the adoption as well. I think that's really great. Anything else you want to add for Spark 4.0?
No, the only thing that I think is like there is a preview release. I mean, if you are a Spark enthusiast and user, you can go ahead and try it. We have already tested it internally with our engineering team. It looks pretty amazing. Obviously, it's not the release version. It's just a preview one, but it's really promising. It has a lot of features out there you can test. So go ahead on the Apache Foundation, the official Apache Spark, and you can find a preview image, and you can test it.
Awesome. Well, that concludes another great episode of InstaBlinks. Once again, thank you, Hichem, for joining me, and we will see you all next time. Thanks.
Thanks, Brian. Thanks for having me.